Okay, today we have our speaker Mark Micrin to join us. Today we'll talk about the topic of automating production level machine learning on AWS. And um, Mark is an AWS and a cloud-based solution specialist and a relationship builder and practice manager of data science and engineering at Onica. His passion is in data, AI, and machine learning. He also loves promoting AWS data and machine learning services through webinars and events and passing the knowledge and passion to others. Okay, I will give the screen to Mark, then Mark can start to share their presentation. Hi, Mark, can you hear me?
Yeah, you, William. Appreciate the introduction. Thanks very much. Let me just start sharing here.
Yep.
You can see my presentation okay?
Yeah.
Perfect. So thanks again, William. And hello, everyone. Thanks for joining today's session on automating production level machine learning on AWS. My name is Mark McQuaid. As William mentioned, I'm a practice manager with Onica in our data science and engineering practice. So in our practice, we work in all things data and all things ML, okay? I also have Jerry George with me today. Jerry is a data science architect on the team, and he will be moderating the chat and answering all of your questions today. So, feel free to write your questions throughout, and we'll get to as much as we can at the end, and Jerry's gonna handle all that, so. Now, today I just want to take you through, a solution to, it's called the model factory solution. It's kind of what we coined it, but it's not a product, right, per se. It's more of an architectural pattern to, the emerging challenge of operating ML models in multiple environments and taking them all the way from dev to production. Okay, and as I said, we kind of coined that the machine learning model factory. So just a quick introduction to Onica. So what we're an all-in APN Premier Consulting partner. So all-in meaning we're AWS exclusive. We're not multi-cloud. 100% focused on helping customers be successful within the AWS cloud. So we feel we developed a certain mastery of the platform of AWS and strategically chose to do this. With AWS based on the breadth of services that's in that cloud. Cloud native thinking, everything we do is cloud native first and foremost, delivering results that leverage the full power of the cloud. Outcomes designed to last. So we ensure the cloud keeps delivering value without rework, right? Long after we've wrapped up an engagement with a client. And we're all about the people, right? We approach all our projects very collaboratively. So this allows for the teams we work with to gain new skills and continue down the path to success that we have started together. As you can see on the right, we've achieved a number of AWS competencies, which allows us to drive our customers' success wherever they are in their cloud journey. Now, the machine learning competency is worth pointing out. That's our newest competency. It's actually extremely hard to get the AWS machine learning competency. I believe there's 26 partners that have it. So we're pretty proud of achieving that. And the 1,600 plus AWS certifications is also something I like to point out. That's something we're all pretty proud of at Onica. So operationalizing machine learning models can be challenging, right? So I'm sure most people do understand that, but it's worth pointing out some reasons why. So I'll kind of just talk a little bit about some of those challenges here, right? So deployment, automation, and scalability. So getting machine learning models from a dev environment all the way to production quickly is typically not something data scientists focus on. This is more of a DevOps or an infrastructure team thing. Reproducibility of models and predictions. So it can be difficult to reproduce a model's output when moving it from one environment to another, right? So moving it from a dev to a QA. This requires careful tracking of library versions and data sets. Diagnostics, performance monitoring, and model drift. So it's most likely your data scientists will have multiple models running simultaneously, in multiple environments using different data sets and different parameters. So this makes it, almost impossible to track a model's lineage. Explainability for governance and regulatory compliance. So one of the most important aspects of governance and regulations, especially if you're dealing with any kind of auditors, is tracking and explaining everything your model is doing or has done, okay? Collaboration. So data science teams often face challenges in how they manage models as they pass through different stages of the machine learning workflow. So this could be with respect to model versions, annotations, and model history. So as you can see, there's many challenges that businesses may face when trying to operationalize their machine learning, right? It's not simple, it's not clear cut. And as you see on the bottom of this slide, it's really something worth mentioning, right? 60% of machine learning models never actually make it to production. So that's actually fascinating. So here I'll just go through it quickly about the agenda for today. So we're going to talk about a little bit why customers need ML ops in general. Then we're going to go introduction into the model factory framework, some of its features, how it works. Then we'll talk about some customer benefits and value prop, and then we'll go into a Q&A. So as I mentioned, Jerry will be monitoring the chat, so feel free to ask all your questions. And as I talk through this, it can get complex, right? It's not the simplest thing to speak about on a webinar, so it can get complex. It can get a little heavy. So feel free, ask the questions as you can. Reach out to me after the fact on LinkedIn. I'll put my email at the end if you want to get any more information. But as I said, I try to simplify it as much as possible, but it can get a little complex. So we've entered the age where no business plan is complete without an ML strategy, right? Companies are realizing the value of using machine learning to drive better outcomes for their businesses. In addition to using their data in a reactive mode with business analytics tools or BI tools, companies are harnessing the predictive power of their data with machine learning now. So as a result, machine learning models are becoming as an important tool in business operations as data processing and data analytics tools were and have been for the past decade, really. As well, getting your ML models to production in a timely manner is key. However, developing domain-specific ML models is only the first step in your strategy. Operationalizing, your models and taking those models to production to drive business insights is more complex than people think, right? And it's just as I showed on a couple of previous slides there, that the challenges associated with this. So what we see today in a lot of organizations is that there's a lot of research and development that goes into the actual model development, right? However, the models never get to a production environment due to the disconnect. Mainly, it's due to the disconnect between the operations or data ops teams and the machine learning engineers. So another common problem we see is that models tend to increase. Models tend to multiply based on the use case and into different environments as well. So one example of this, think of a bank operations and the number of different areas that can benefit from predictive data analysis. And that could be from identifying fraudulent transactions to risk assessments of mortgage applications. So data scientists will create domain-specific models and run many experiments, first starting out in a dev environment and then moving them along the chain into a testing environment next. So this results in multiple models running simultaneously across different environments using different data sets and different hyperparameters. And that's, as I mentioned again, when you get into this, it becomes virtually impossible to keep track of a model's lineage without an operational solution in place. So we hear a lot from clients that it might take them just a few weeks to develop an ML model, right? That addresses their business needs, it's good to go, it does the job. Yet it will take them months to have this model deployed into production. So what we see out there is that people are looking for a solution that will combine data prep, model training, development, model monitoring, all into one workflow or kind of framework across multiple environments, all while maintaining strong governance and strong security controls. So why DevOps is not enough? So the DevOps culture and application lifecycle management have become a standard in the IT industry really over the last decade. It emerged to fill the gap between the organization's ability to develop application code and the way to efficiently deploy, update, test, scale, and monitor those workloads. So mature CI/CD pipeline needs are largely addressed in application development by the industry-wide standardized tools and best practices that are in place today. Unlike application development, where quality comes from the code itself, the quality of an ML model comes largely from the data features used to train it. So the importance of these data features cannot be understated. Their quality drives your machine learning model's performance. And it's worth mentioning, machine learning models are really still in their operational infancy, right? Additionally, data might change daily, and the data that was used for predictions that you did for today might be significantly different from the data used for model training a month ago. So in this case, the production model needs to actually be retrained and go back into that kind of development phase. So as a result, ML models lifecycle is significantly different from application lifecycle. So in fact, we actually had a customer in the fraud space who wanted to push production models every 24 hours to account for new threats. So the customer would actually retrain and redeploy their model every day to be able to account for this drift in data. Again, that's something that is impossible without a mature solution in place to allow that to be performed. Now here, this slide just talks to, this kind of a high level look at the machine learning lifecycle steps, right? So there's many steps to an entire machine learning lifecycle, as you can see. Each step has its own set of challenges, really. So you have your data ingestion, data analysis, data transformation, data validation, data splitting, right? Then you get into training, building a model validation. Then you're going to train it at scale. Then you're going to roll it out. You're going to serve it, and then of course you're going to monitor and you're going to log it. Okay. So, the machine learning lifecycle is complex, and with all these steps, there's the associated challenges in mind, right? So this is the reason behind why we developed the model factory framework and the architectural pattern of it. So with that, I'd like to introduce the Amazon ML stack, right? So AWS sinks a lot of energy, resources, time into their AI platform. If anyone is familiar with AWS, you'll know that that's kind of their flagship offering now, really, is their AI stuff. So it's a 3-layer stack, as you can see from this slide. So you have your top level layer, which is your AI services layer. So this is your pre-built artificial intelligence services, right? So no data science or machine learning expertise required. They're really built for developers to use and to put artificial intelligence into their applications very easily. And they cover different domains, right? So you have, your vision services, and that's, anyone who knows AWS will know some of these, obviously, services. This is Amazon Recognition for vision. Then you have speech, that's Amazon Poly and Transcribe. So that's text to speech, speech to text. And then you have your language services. That's Amazon Translate, which is a translate service, and Amazon Comprehend, which is an NLU, NLP service. Then chatbots, which is Amazon Lex. The name is not mentioned there, but conversational bot service. And then some of the newer services. You have Amazon Forecast, which is time series forecasting, and Amazon Personalized, which is a recommendation engine. So as I said, these services are all ready to go. They're built for developers to just, put right into their applications, no ML expertise required. Then your next layer is your ML services layer. So this is your Amazon SageMaker layer. So think of AWS's end-to-end machine learning platform is SageMaker, right? So everything's wrapped up into one. You have the ability to build, train, and deploy machine learning models, all from within the wrapper of SageMaker. Right. So under the build area, you have the ability to do some, data labeling using a service called Ground Truth. You could use the SageMaker built-in algorithms. You could actually grab pre-built models from the the AWS marketplace for machine learning. And what that is you can actually just go and buy a model that someone's selling. So, it gets rid of the heavy lifting from your part. And then notebook hosting. So just think of Jupyter notebooks in the cloud, right? So that's part of the build area of SageMaker. Then you have the train area, right? So one-click model training and tuning. Optimization, which is Neo. SageMaker Neo enables developers to train machine learning models once and run them anywhere in the cloud and at the edge. SageMaker Neo optimizes models to run up to twice as fast, really. Hyperparameter optimization and support for reinforcement learning. Now in the deploy section, one-click deployment and hosting. auto scaling built in. You could put everything into a virtual private cloud, private link, and elastic inference integration. So elastic inference is an accelerated compute service that allows you to attach just the right amount of GPU powered inference acceleration to any SageMaker instance or EC2 instance for that matter. And that's the ML services layer. It's that whole end-to-end SageMaker platform. And there's some new stuff with SageMaker Studio going on now. So I would encourage you to if you're interested in SageMaker, read up on it. It's actually, I would say SageMaker is probably the thing that AWS invests the most time and effort into is their SageMaker platform. And then you have your ML frameworks and infrastructure layer. So this layer is for full control from your data scientists and ML engineers. So they don't have to work in the confined space of SageMaker, really, right? Full access to the underlying resources. So, this is your EC2 instance running, deep learning AMIs, right? And they're probably GPU instances. And you can, run your own frameworks in those instances, right? You could, TensorFlow, MXNet, PyTorch. And it just gives your data scientists more control, right? So if you want to step outside of that kind of confined space of SageMaker, you use the third layer. So as you can see, AWS tries to check all the boxes when it comes to using their platform for any of your ML needs. But it is worth noting that the Model Factory framework, it can also function outside of this stack. So what I'm going to be speaking about today, right? It doesn't have to be in this stack necessarily, right? So for example, you could use services like EKS, which is Elastic Kubernetes Service, managed Kubernetes, or Amazon EMR, which is Elastic MapReduce, which is managed Hadoop within AWS. So there's other aspects that aren't in here that the Model Factory framework, kind of works with. And one aspect on this in these layers that's not quite mature in this stack is the lifecycle management and integration components that allow orchestration of machine learning. So, and it's also worth mentioning, we truly believe that each customer is different and should have the flexibility to choose their own platform based on what they're doing currently, right? Their existing processes, their existing tooling, and their existing skill sets. So while AWS provides a great set of services for machine learning, like don't get me wrong, it's fantastic. Some clients may still require end-to-end machine learning blueprints and the ability to run across different platforms with these. So introducing the Model Factory framework. So it's what it is a cloud-based machine learning lifecycle management solution, okay? So what is the Model Factory framework? So I guess by definition, the Model Factory is a machine learning operations framework built on AWS using open source tools that enable rapid development, training, scoring, and deployment of models. So if you can see all these, squares and rectangles here, these are kind of all things that are built in that we've accounted for in this framework, okay? Now, as I mentioned already, Model Factory itself is more of an architectural pattern than a product, right? It's not a product. It's just a way of doing things, right? A way that we've come up with that we feel is the best suited way to do ML ops. The Model Factory, it was built to address the problems our customers were facing, right? When taking machine learning models from development to production. So, one of my peers, who's also a practice manager from within the data science and engineering practice, his name is Goose Mohammed. He goes by Mohammed. He was actually kind of the driving force behind the design of this. He's kind of the brain behind the creation of this architectural pattern. So I just wanted to throw in a quote from him, right? So he said that the primary motivators for the Model Factory was to bridge the gap between data science and operations, and also to reduce the time to get ML models deployed into production, right? It's pretty basic. Also, I wanted to throw a quote out there from Jerry. Jerry, as I said, is on now. He's monitoring the chat. So, Jerry is heavily involved in many of our Model Factory engagements in, building up this platform. So, he's one of our key Model Factory people in-house. So Jerry said, the Model Factory architectural framework provides simple but effective set of processes and tooling to allow data scientists and operations to collaborate, enable model development, automate packaging, and deployment to multiple environments. It does this in a consistent and platform agnostic manner, and more importantly, makes it much easier to integrate existing model code, right? So we're not asking anyone to reinvent the wheel, right? It's more like tailored to whatever you're currently doing, really. So the solution itself is built using open source tools, and it's a flexible framework that allows integration with AWS services as well as industry standard automation tools for data processing. So this could be Jenkins, Airflow, or AWS Code Pipeline, or any of the AWS developer tools. It's worth mentioning that the main concerns of models governance across multiple environments have been addressed as well in this architectural pattern through experiment tracking, which is visible through something as we call the tracking UI. Model Factory also supports deployment of the model into different hosting platforms. So as I said, it doesn't have to be SageMaker. As on the previous slide, it can be K8s, it could be managed Kubernetes EKS. So it supports a variety of that. It also supports a variety of frameworks such as TensorFlow, Scikit-learn, SparkML, Spacey, PyTorch. The solution is highly extendable and can be customized based on the business's needs and domain requirements. And it's an open and pluggable solution allowing use of different CI/CD and ML pipeline tools. So I'm just going to go through some of the challenges I mentioned earlier and how this framework, this architectural pattern solves those challenges. So you have your standardized model development environment for your data science teams, right? So no more multi-environment model deployments and no need for data scientists to worry about which environment to put their model. Automated model deployment across dev, QA, and production. So everything starts out in a dev environment, and through automation, everything gets promoted when ready, right? Obviously, when ready to the next environment and stage. Reproducibility of the model and predictions. So this allows for data scientists to easily duplicate models and model outcomes in many environments. Tools for diagnostics, performance monitoring, and addressing model drift. So Model Factory allows for complete tracking of your model, allowing easy access to diagnostics, performance of that model, and catching that model drift. Model lineage for governance and regulatory compliance. So Model Factory also captures all model lineage for easy details, description, or explanation of your model. Platform for collaboration across data science teams. So data scientists no longer have to work in individual silos, okay? Just opens everything up for collaboration. Accelerated ROI and faster time to business insights. So Model Factory allows you to take those models into production in a timely fashion, allowing you to get the return on investment you envisioned when you decided to start using machine learning in your business in the first place. And that is, I mean, if someone's gonna decide they want to, expand their business into the ML world, that's the point, right? It's getting that model into production. It's not building it and having it sit in a dev account, getting zero ROI. So a little bit of the model development lifecycle. So without the Model Factory compared to with, right? When we're talking about that life cycle that I showed earlier. So without, the whole life cycle could take months with 25 plus steps between, right? You start in a local dev, you move to another dev, probably a cloud dev environment, then to QA, then to prod, right? So with Model Factory, that we've trimmed that down to 10 or so steps and just weeks, right? Not months, weeks. Without Model Factory, manual handoffs between various teams. With Model Factory, so everything's automated, right? Automated deployment between environments with controlled access as well, right? Controlled access to data teams needed for specific steps. Without Model Factory, cycles of troubleshooting between data scientists, local dev environment, and then data engineers development environment. And with Model Factory, it's one source of truth, right? Everything, one source for experiment tracking, project packaging, for easy source control and reproducibility. So I mentioned that the Model Factory solves the challenges that I talked about, but both from the perspective of data scientists as well as operators, right? So now I'll go into a very simplistic approach to align some of those solutions to the overall model lifecycle features. At the time short, right? We don't have a ton of time, so I'm not going to get into too much detail here. So I'll just kind of skim over some things, but again, please ask questions as you see fit. So model development. So it's worth mentioning as well that the framework, the architectural pattern, right? The Model Factory, it's really focused on model development, right? That's kind of where the focus lies. It lies in the model development piece. So as I go through these slides, you'll notice that there's a lot of pieces for the model development compared to the deployment or anything like that. But it's because that's where the main focus is, right? So as you can see, the ability to develop an agnostic of the development environment, right? Ability to easily onboard existing models into the model factory using curated list of notebook templates and proprietary manifest DSL that caters to different use cases. I'll show an example of a DSL file on the next slide. Ability to recreate both training and scoring environments with ease, right? Ability to track and tune both manual and automated hyperparameter tuning jobs. Ability to consistently package models and model code agnostic of the domain. Ability to test multiple versions of the same model in a QA environment for performance and degradation. Ability to debug and exit long-running model training jobs early, which are not performing for a given set of features. So as I mentioned, this is an example of what the DSL looks like. A quick look at it. I just wanted to showcase it because I mentioned it, and I wanted people to not be, kind of have a feeling for what it was. It's, as you can see, it gives you a full detail about the model, right? So it's the model name, the type, container definitions, entry points, to the actual resources used for different environments. So it also includes the mechanism to request spot instances. So if anyone's familiar with AWS, spot instances is unused capacity EC2 that you can get at 70% off the price of just a standard on-demand EC2 instance. So from a cost saving standpoint, or you could use ephemeral EMR or Kubernetes pods, right? For example. So as I said, it kind of just defines the entirety of the model. So now speaking specifically of the development environment, when you talk about ML engineers or data scientists working, you would likely see that they tend to be very attached and opinionated to the development environment that they use, right? That they get the most out of in terms of features or the experience that they have accumulated over the years working with. So there's three primary model environments we cater to with the model factory. And that's notebooks, right? As you can see, that's IDEs. And finally, it's automated environments. So that could be AWS tooling, such as the AWS developer tools, or it could be Jenkins, really, right? And our recommendation has always been to cater to the team's existing development environments from the get-go, right? You don't want to switch people from what they're used to, from what they're good at, from what they want to use. You keep everyone, they keep using that stuff, and you just cater to them. So integration. So two main added advantages here is based on our extensive experience working with different data teams, ops teams, and even soon to be ML ops teams, right? We have created notebook templates and scaffolding to allow easier onboarding. So what exactly is that, right? Notebook templates allow data scientists to place their existing code into predefined placeholders and run the model against our centralized tracking server that I mentioned earlier. So essentially, this allows data scientists to be abstracted away from the complexity of the underlying platform and the underlying infrastructure where the code runs, right? It allows them to focus on writing code to build models, which is what a data scientist wants to do and probably gets paid to do. Additionally, we provide scaffolding, both scripts and that DSL I showed earlier, to allow easier build, train, and integration with notification systems for training, deployment, and monitoring of the model onto a desired platform. So those DSLs that I showed earlier, they really just allow us to bridge that gap between the data scientists and the operations team. So dependency management. So data scientists need to be able to run the same model training against different hyperparameters to evaluate the model's performance. So one other challenge that machine learning engineers face is an expectation that they are able to reproduce the training runs if they so desire, or even share the environment with other data scientists who are able to recreate the environment. So we always recommend using tools such as Conda and Docker images to help in this regard. So Conda, of course, has been well tested and is a proven tool in the data science space. And speaking specifically to the Docker images, we actually had an interesting use case that we came across where a customer didn't have internet access in their model development environment. So we used pre-built Docker containers, which essentially packaged all of the dependencies. And then these Docker images were stored in AWS Elastic Container Registry using a private network. But Elastic Container Registry, if you don't know what that is, that's essentially Docker Hub within AWS. And we also designed container image rollout architecture as part of the CI/CD pipeline for them. Tracking and tuning. So tracking to a centralized server becomes a critical part to the data science workflow. Traditionally, when data scientists run experiments, the data or the parameters with which data scientists work with can be lost with no traceable revision history. So even though we have a mechanism to reproduce the experiment environments using tools like Conda, they do not know the flags provided to the program. They don't know the hyperparameters or even the dataset version. So to solve this issue, we have to allow for proper tracking of model runs. We also have mechanisms to track not just general runs, but also to log hyperparameter tuning runs and compare them using a plot. So besides this, there's also enhanced logging and metrics for popular frameworks such as TensorFlow, Keras, and so on. This allows for data scientists to dig down deep into the detailed metrics, such as loss or accuracy per epoch. The callbacks that are set up will be able to automatically log a summary and import metrics for the model over the course of a training run. So consistent packaging. So we talked about how we solve the replicating or reproducing model training environments. However, I haven't mentioned anything about replicating model inference environments or how we handle the idiosyncrasies of different ML frameworks. So for example, binary format for TensorFlow-based models would be different from that of PyTorch. Besides, it's not just the model itself. We have additional artifacts like plots, metadata about the model, or dependent scalars that could be Pickle, it could be HDF5. So there needs to be a consistent mechanism to package the model or models and associated artifacts and target different platforms. Or else the operators would need to concern themselves with details on how to serve different types of models and formats. So the Model Factory allows for and provides this consistent packaging. So A and B testing. So now that you have a model developed and trained, the next step is testing the model. So with proper testing on a different data set, we would not be certain that we have not overfit the model. We would need to confirm the accuracy and the loss percentages. So with this step, we provide a different data set, or even a better it could be a snapshot of the actual unlabeled production data. After sending the data for prediction, we capture the requests and responses over a range of time and compare it to the data set's ground truth. This way, we are able to assess the true model performance. Now, in some systems, we can take this even further by testing multiple model endpoints and comparing the model performance over a given period of time. Now, if you notice a pattern, you can imagine this process can also help us do real-time model monitoring of production model performance. All right, so that was kind of a lot for the model development piece. So now onto the model deployment. So model deployment supports multiple platform backends for the same model code, right? Now this could be SageMaker, EMR, as I mentioned, EKS. It has support for promotion view. So this is dev, stage, prod. Tracks revision history on all upstream artifacts and notebooks, and supports real-time, batch, and streaming inference pipelines. Now, specifically for the training or inference pipelines, a common question we get from customers is how does the ML pipeline tie into the existing data ingestion or transformation pipeline? So a typical ML lifecycle contains steps around feature engineering and enrichment, right? Minor pre-processing or even post-processing. So when there are 2 or 3 data pre-processing or post-processing steps, they tend to use orchestration tools, right? And this could be Airflow. Another use case is where customers have not one model, but they use multiple models to get the generalization. However, it is not a single model, but a combination of these models in a sequence or based on some business criteria. So this can be very common in an organization. So recently I've seen 3 to 4 organizations that extensively use this model. So in such scenarios, we need to provide a state machine engine of some type to orchestrate a workflow. So we do provide support for popular frameworks like the data science, so SDK, step functions in AWS, Apache Airflow, or Argo. So on to monitoring, right? Model Factory monitoring captures model requests and responses for comparison for detailed analysis, provides data quality metrics using Apache DQ, provides infrastructure monitoring, and tools to ingest both data drift and model drift, which is huge. Now, from a monitoring standpoint, we look at 3 domains involved, right? The 3 domains involved are infrastructure, platform, and then the data or model, okay? I won't talk too deeply about monitoring since it's kind of, it is relatively the same concept as model testing. But one thing I'd like to point out here is the concept of data drift, which I've mentioned a few times, right? So as you can imagine, the way model is able to generalize a problem and provide labels for a desired problem is largely dependent on the data that we provide for training, for validation, for testing, right? So this data can be obsolete depending on the type of data, which is termed as data drift, okay? So for example, sales forecasts based on a set of SKUs on an e-commerce clothing store may be largely different from what people will obviously buy in the summer months and what they buy in the winter months. So data drift can be even more serious for certain other areas, such as fraud as well. So we like to account and capture all the data drift and model drift. And governance and security, of course, right? So clear separation of data and model artifacts. Granular access controls using AWS IAM and bucket policies for model feature stores, models and all associated pipeline artifacts. Rule-driven access, right? This could be cognito user pools or IDPs. IAM authentication for access to backend data stores like RDS. RDS is the relational database service from within AWS. IAM, I said it a couple of times, is identity and access management within AWS. So that's the identity store. Cryptographic keys and management and control using AWS KMS. KMS is the key management system. Data lineage and traceability using tools like DVC. Delta Lake could be another one. An extensive use of tagging for auditing and accounting. So that's kind of a lot of the pieces rolled into governance and security. So how it works. So like I said, it can get complex, it can get heavy. I went through a lot in a short period of time. What I wanted to do now is I like to show an architecture diagram of a sample of what it exactly means, what I've been speaking about. Me personally, I like to see visuals. So I'll show you a quick diagram and then I'll just summarize, what's happening. If you're familiar with AWS services, you'll recognize a lot of the pieces in this diagram. And like I said, for me personally, just seeing a nice visual kind of allows me to get a better feel for from what I'm hearing. So as you can see here, we have 3 stages: a development, a staging or QA stage, and a production stage, right? So this is, again, this is a sample with the model factory, nothing set in stone. It's just kind of an architectural pattern, as I keep saying. So, you can swap things in and out as you go, right? So in the development phase here, data scientists perform exploratory analysis of the data and the model. They then evaluate the enriched features, choose an appropriate algorithm for the problem domain. They may develop locally in an IDE or remotely on a Jupyter Notebook solution of their choice. Then at the staging or QA stage, data scientists feel sufficiently confident about the model and wish to test the model using a larger production data set, which has undergone sufficient refinement to comply with the organization's security and compliance policies. So in order to facilitate the testing, all the data scientists need to do is wrap up a sample blueprint, as I mentioned a couple of times, and that's this project file, and model code, and then push it into a Git repo in the staging branch, okay? And then at the production stage, data scientists have evaluated and tuned the final model algorithm against the production data set under various hyperparameters. The data scientists and operations have an agreement on the desired model using a global unique identifier for the experiment run. So we use this unique identifier to promote the experiment by updating a production branch of the Git repo. So upon doing this, the final model is pushed to a production endpoint and can be used for the downstream applications. So as you can see, it's kind of a busy slide. There is a lot of services that are in play here and being used, which is kind of goes hand in hand with me saying it can be a little complex, right? It's not a simple architectural pattern that I'm talking about here. So I hope the visual helped some understanding, somewhat of further understanding in the topic. Now, I just wanted to talk quickly about a couple customer success stories, just because they're good to highlight what people have utilized this framework for and how it was successful for them. So, a water and utilities company. The problem was the customer had several machine learning models already designed and implemented in various environments, and was seeking a consistent mechanism to quickly track the best experiment runs, as well as managed hosting platform with automated deployment and promotion pipelines, right? So we proposed the model factory solution as part of a phase one, of which the engagement, we tuned and integrated the models with ML Flow, which allowed us to track, package, and deploy the models into the SageMaker platform. It is worth mentioning it doesn't have to be ML Flow. It could be Kubeflow, but in this case, it was ML Flow. ML Flow is an ML framework agnostic and provides support for TensorFlow, PyTorch, Keras, right, Scikit-learn, SparkML. So as part of the phase two of the engagement, we utilized AWS services such as Code Pipeline, Code Build to design and orchestrate the promotion pipeline for training and deploying inference endpoints and batch jobs. So essentially, what we stood to achieve through this ML pipeline is that it facilitates and ensures a quick turnaround time for training and deploying the models to production, right? It's very simple at the end of the day, what we're trying to accomplish here. So AWS services used as part of this solution were SageMaker, EMR, Code Pipeline, Code Build, Amazon Athena. I don't think I've mentioned that yet. Amazon Athena is, a SQL query service, an ad hoc SQL query service from within AWS. S3, which is cloud storage, and ECR, which is that Elastic Container Registry I spoke about earlier, which is Docker Hub in the cloud in AWS. Third-party applications or solutions that we used here were Python, ML Flow, TensorFlow, Horvath for distributed training, Petastorm for accelerated ingest into TensorFlow using Parquet, and some of the outcomes, right? So the customer was able to consistently package and deploy all of their models. They were able to track and compare their parameters and accuracy metrics across different experiments. They're now able to uniquely identify each experiment run, models, and any associated artifacts using that unique ID that I mentioned, irrespective of the ML framework utilized. They were able to get a quick turnaround time to pre-processing, training, and testing the models by simply checking in the model code changes into source control, right? It was that easy. And then another success story, quick one I'll just go through, is a credit union we did. So the customer is a national federal credit union that was seeking to develop cloud-based infrastructure to support its data science practice and develop predictive models for credit worthiness. So existing processes for data scientists were informal, decentralized, which increased the security exposure and privacy concerns, okay? So the solution was, designed and implemented the model factory framework as a, kind of the consistency here, to provide an enterprise-grade data science and machine learning infrastructure. The model factory enabled rapid development, training, scoring, and deployment of models. There's a pattern with all this, right? It's at the end of the day, it's a simple thing that's being accomplished, and that is that rapid development, that rapid training, scoring, and deployment of models, right? Cloud-based approach to provided availability from anywhere while also keeping sensitive data under company control. And features implemented included experiment tracking, the tracking UI, as I touched on earlier, project packaging for easy source control and reproducibility, multiple deployment interfaces, CI/CD and integration with ML Flow. Again, this was ML Flow, but again, you could use Kubeflow. And proper governance was also put in place and proper security. So with that, I would just like to say thank you. And any questions, please, write them in the chat. As you can see, also, you can reach out to me at my email. That's mark.mcquaid@rackspace.com. I don't know if I actually mentioned that. Onica is a Rackspace company, so that's why it's rackspace.com. And there's my LinkedIn, linkedin.com, Mark-McQuaid, Mark-McQuaid. So please add me to LinkedIn and ask any questions through that. You can ping me on an email or LinkedIn as well, or ask them in the chat right now. Up to you.
Okay, thank you, Mark. Thank you so much.
No problem.
For our attendees, if you have any questions, please you can input at the Q&A chat box, and we still have time, and then we can discuss these questions. Yeah, I saw one question here. Someone asked, will we be able to access a recording of this webinar later? Yes. After normally, it will take 3 business days for us to upload the video to the Ideas YouTube channel. So next week you can visit our the YouTube video of ideas to find the link. No, find the video of this webinar, and all our webinars will be recorded and put it on our YouTube channel. Okay. Any other questions?
All right. Well, if there's no other questions, I just want to say thanks again, everyone. I appreciate you taking the time to listen to me speak. And hopefully I can do it again soon and reach out to me if needed. Appreciate it.
Okay. Thank you so much, Mark. Thank you for your time and your wonderful talk. And we're going to send you an invitation since we are calling for speakers for our AI Global Conference in this October. Definitely want to invite you to join us as well.
Absolutely. More than happy to.
Okay, great. Okay, thank you, everyone. Thank you for your time. And
thanks, everyone.
Week.
Thank you. Bye.
Bye.
Bye-bye.